Hello everyone, welcome to the discussions on the past year questions. This video we shall discuss about the mechanic paper 4, 2024 October-November paper 42. Let's take a look at the first question. We have a graph over here. The velocity of a particle moving in a straight line t at time t second after leaving the fixed point O is v meter per second. The diagram shows a velocity against time graph, which models the motions of the particle from t equal to 0 to t equal to t. The graph consists of 4 straight line segments. The particle accelerates from rest to a speed of v meter per second over a period of 4 seconds and then decelerate at 5/3 meter per second square to instantaneous rest over the period of 6 seconds. The particle then travels back towards O, reaching the maximum speed of 3 meter per second before it's coming to rest. Okay, so the diagram over here mentioned that for the graph, you will be having accelerations over here. This part is accelerations. Then after that, you're having decelerations. Then you come to rest, instantaneous rest, and then you go backward, reaching the maximum height of 3 meter, maximum velocity of 3 meter per second, maximum speed of 3 meter per second, and then after that you go back to become rest again. Okay, so this is the diagram. Now we are looking for part A is looking for the value V. So to look for the value V, we can see that the question is giving you that the acceleration here is 5/3 is deceleration, so supposed to be a negative. So if you're taking this point as a 10, 0, and you're taking this point as a 4v, then by using the gradient formula, if you're using the gradient formula, it will be v minus a 0 over the 4 minus a 10 is equal to negative 5/3. So from here, you can find that your v is equals to the 10 meter per second. That will be the answer for the part A. Then we're moving on to the part B. Given that the total distance traveled by the particle from O to T is 68 meters, find the value of T. So they giving you the total distance travel. Total distance travel means the total area here. The total area here. So we are looking for the total area here. So I separate them to become 2 triangles. Okay, so the triangle on above the x-axis. Okay, so this triangle above the x-axis and the triangle below the x-axis. These two areas add together must be equal to 68. Okay, so the total distance equal to 68 means that the total area of graph is equal to 68. Okay, so the total area for the triangle, the first triangle is the base is 10, the height is a v, so half times base times height, so it's half times the base times the height. The v we have found is 10, and then the second triangle is below the x-axis. The area will be negative, but we know area will be positive, so we can just the height over here, we don't choose -3, we choose +3. So the distance over here is t minus 10. Okay, so this one, it will be t minus a 10 multiplied by 3 is equal to 68. So we simplify them. This one you get 50. This one you get 3 over 2t minus the 15 equal to 68. And then just press a calculator, solve everything. You can get the answer as t equal to 22. Okay, so that will be the answer for the question number 1b. And now we're moving on. Question number 2. Okay, now we take a look at question number 2. A block of mass 20 kg is held at rest at the top of a plane inclined at 30 degrees to the horizontal. The block is projected with a speed of 5 meters per second down a line of greater slope of the plane. There is a resistant force acting on the block as the block moves 2 meters down the plane from the point of projections. The work done against the resistance is 50 joules. Find the speed of the block when it's moved 2 meters down the plane. So we can draw a diagram over here. This is a 30 degree. So you have a particle start from moving down with a speed of 5. Moving down with a speed of 5. And when it reach over here, this speed is a v. You do not know the value, but you know that the distance here travel is already 2 meters. Okay, so this is the situations. We can use conservation of energy to do it. Okay, so I will use conservation of energy to do it. So I will just write COE, conservation of energy. We have the, maybe I write below here so that I can put my formula over here. So I have a potential energy loss is equals to the kinetic energy gain plus the work done by the resistance. Okay, so this is the relationships of the energy. So the PE loss will be mgh, the KE gain will be half m of the v square minus the u square. The work done by the resistance is the resistance force multiplied by the distance that you travel. Okay, so what is my m? M is 20 kg. The g is a 10, the height over here is this height. So this height is actually 2 sine 30 degree. So we just write 2 sine 30 degree equal to the half m of v square we do not know. The u is a 5. Then the question mentioned that the work done by the resistance is 50 joule. So actually there's no need for you to write FRS. We can just straight away remain this one as a work done by the resistance. And as the value given in the question is 50 joule, so we just write 50. So now what you need to do, just to press a calculator, this one will be 200 equal to the 10v square minus the 250 plus 50. So your v square is equals to the 40. Then your v is equal to square root of 40. You can write the answer as 210 meter per second. Done, just like that. That will be the answer for the number 2. And now we're moving on to question number 3. Okay, question number 3. A cyclist is riding along a straight horizontal road. The total mass of the cyclist and his bicycle is 90 kg. The power exerted by the cyclist is 250 watts. And at an instant when the cyclist speed is 5 meter per second, the acceleration is 0.1 meter per second squared. Find the value of a constant resistance of motions to the motions on the cyclist. Okay, so we are moving in the horizontal road. So we resolve the forces horizontally. We're supposed to have a driving force minus the resistance force is equals to ma. So we should know that the power is Fv. Okay, the formula for power is Fv. So which means that we can make the force over here become P over V. Okay, that is your driving force. So I change this to become P over V minus the resistance force is equal to the Ma. My power is given as the power given is 250 watts. Then the velocity is 5. The resistance force you do not know, and the m is 90 kg, and the acceleration is 0.1. So this is what they give you. So again, just press a calculator. You get a 50 minus 9, you get a 41 Newton. Done. That will be the answer for the part A. So now we're moving on another sections. The cyclist comes to the bottom of a hill inclined at a 2 degree to the horizontal. Given that the power and the resistance to the motion are unchanged, find the steady speed. Steady speed means constant speed. Which the cyclist could maintain when riding up the hill. So when you're going up the hill, okay, you are, if you resolve the forces along the inclined plane, so you will have a driving force minus a resistance force. This time you have to minus your weight, mg sine theta. Then it will be equal to the ma. Okay, so your driving force again is the P over V. Okay, P over V, and then minus the frictional force minus the mg sine theta is equals to the 0 over here because of a constant speed, because of steady speed. Steady speed, that will give you your acceleration is a 0. So we change the P become, they say the P is unchanged. P is unchanged. The Fr is also unchanged. So the B is a 250. The V you do not know. The frictional force is given as, just now in the answer for part A, the frictional force is 41. So it's 41 minus the M G sine 2 degree is equal to 0. So at the end, we just need to press a calculator and everything. So this one, you just try to move here and there yourself. Then we can get the answer as 3.45 meter per second. Correct the 3 significant figure. Okay, done. That will be the answer for the question number 3B. And now we're moving on to the question number 4. Okay, question number 4. We have a diagram here. The diagram shows two particles A and B of mass 0.2 kg and 0.1 kg respectively. The particles are suspended below a horizontal ceiling by two strings, AB and EQ, attached to a fixed point P and Q on the ceiling. The particles are connected by a horizontal string AB, and the angle APQ is 45 degree, and the BQP is theta degree. Okay. Each string is light and inextensible. The particle is in equilibrium. Find the tensions in the string AB. Okay, so over here, actually, we just need to split them into two. We just, like this. This is the tension of AB. This is the tension of AB. This is the weight, 2 Newton. This is the weight, 1 Newton. This is the tension of Q. This is the tension of B. Okay, so we will take either this diagram or this diagram out to solve the problem. Over here, we need to take this diagram out because here we have an unknown theta. So if we take this diagram out, you just need to draw it out over here. This is the dB. This is the weight of 2 Newton. Then this is the DAB. And we are having this one as a 45 degree. So if you at A, if you resolve the forces vertically, then you will have dB sine 45 is equal to 2. Okay, then we will be having dB is equal to the 2 sub 2. That will be your answer for dB. Then if you resolve the forces horizontally, you will have dB cos 45 is equals to TAB. Then your TAB will be equal to the 2 sub 2 divided by 1 over sub 2. Cancel it off, you will get TAB is a 2 Newton. Done for the question number 4. Now we're moving on to the question number 4B. They want you to find the value of theta and the tension in the string BQ. So tension in the string BQ, that means we want to find this and this value, these two values. So we will take the diagram out. I will draw it over here. This is the tension of DBQ, tension Q I for DQ. The weight over here is 1 Newton. And this is a DAB. And this will be your theta, just like that. So at B, if you resolve the forces vertically, you have a dq sine theta is equal to 1. And if you resolve it horizontally, you have a dq cos theta is equal to the DAB. So we know that DAB is 2 Newton. So I call this one equation 1. I call this one equation 2. I just take the number 1 divided by number 2. I will having tangent theta is equal to half. Then from here, I can just press my calculator to get the answer of theta in terms of degree. Correct, the 1 decimal place is 26.6 degree. And if I take the 1 square plus 2 square, then I will have dq square is equal to the 1 square plus 2 square. My dq is actually a 35 Newton. Done. That will be my answer for the question number 4B. And moving on, we have question number 5. Okay, now we take a look at question number 5. Two particles P and Q of masses 2m and m kg respectively are held at rest in the same vertical line. The height of P and Q above horizontal ground are 1 meter and 2 meter respectively. The P is projected vertically upward with a speed of 2 meters per second. At the same instant, Q is released from rest. Find the speed of each particle immediately before they collide. So over here, we have a ground here, and let's assume that the P is here and the Q is here. So this is the Q, this is the P. Q is going down, P is going up. And this distance is 1 meter apart. This is a 1 meter from the ground. So P is moving up with the speed of P as 2 meters per second. Then the Q is going down actually from rest. Okay. So at Q, our formula for the displacement is UQT plus half GT square. So we will have SQ equal to the 5T square, equation 1. Then at P, we have SP equal to the UP minus a half GT square. Sorry, I forgot to put a D here. So this one is half GT square. So this one will be SP is equal to the 2T minus a 5T square. That will be my equation number 2. When they collide means the first equation plus second equation, that means the SP plus SQ must equal to 1. So if you add together, you will have 2T is equal to 1. Then you will get T is equal to half. That means P and Q, they collide half second later after they projected. And we want to find the speed for each of the particles. So at P, the speed is given as a VP equal to the UP minus the GT. So UP. So this one will be a 2 minus a 10 times half. You get a negative 3. Then at Q, your VQ will be the UQ plus GT. That will be a 0 plus 10 times half. You get a 5. But you're looking for speed. So therefore, the speed of P is equals to the 3 meters per second. And the speed of Q is equal to the 5 meters per second. But over here, there's something for you to aware of. They are having a different sign. Q is positive, the P is negative. Now, you need to understand that at the beginning, I assume P going up as positive. So, but when I have negative means that it will going down. It's going down half second half second later when they collide, actually B is going down. But Q itself, at the beginning, I treat it going down as positive. Now come to here is still positive. That means the Q still remain going downward. So this is something you have to be aware of. So we can put a highlight or remark here to mention that this is going down, going downward. This is also going downward. Both of them is moving in the same directions immediately before they collide. Okay, so this is important for us to go and do the part B. So for part B, it is given that immediately before the collision, after the collision, the downward speed of Q is the 3.5 meter per second. So since they have collisions, we need to use conservations of linear momentum, conservation of momentum. So I would write PCLM over here, principle of conservations of linear momentum. So there will be the MP. So since now I am both of them in the same directions, so both of them in the same directions, I will treat my velocity of B as 3, not negative 3 anymore. Okay, because both of them is moving in the same directions. So for B, I will treat this as positive 3, not negative 3. So this one M is a 5 equals to the 2M. That is the speed of B after the collision plus the speed of Q after the collision, or the velocity of Q after the collisions. So we cancel everything, the M, cancel all the M. Then you get 11 is equal to the 2WB plus the 7 over 2. Then just move to the other side, and then you can find that the speed of B, the velocity of B after the collision is 15 over 4 meter per second. Okay. So we want to know when they collide, at that moment, what is the height above the ground, okay, when they collide. So when t is equals to the half second, okay, I use, to find the height, we can use SQ or we can use SB, okay. So maybe we use SQ. SQ is 5t square, is 5 over 4, okay. So the height, it will be 2 minus a 5 over 4, and you get 3 over 4. Why need to take 2 minus 5 over 4? Is because the original height of Q to the ground, original height is 2, but Q is moving this way, so Q is moving 5 over 4 meter already. Then the height over here, you need to take 2 minus the 5 over 4. That is the reason we put the height as 3 over 4 meter only. Okay. So after now, after they collide, both of them moving downward. Okay, both of them, after they collide, both of them are moving downward. We are looking for the speed of B at the instant when it reaches the ground. Okay. So over here, when the B reaches the ground, okay, so we're using this formula, V square equal to the U square plus 2GH, okay. But over here, I will call this one V square is equal to the WB square plus the 2GH, okay. So the WB just now, WB is a 15 over 4, so it's a 15 over 4 square plus the 2G, the height is a 3 over 4, okay. Then, but actually we just need to square the whole thing. So let's save the time. Press everything using calculator. You can get the answer as square root of 465 over 10 into decimal places of 3 significant figure. It will be 3 significant figure in decimal. So you have 5.39 meter per second. Done. That will be the answer for number 5. And now we're moving on to question number 6. Okay, now take a look at question number 6. The particle P travels in a straight line starting from a point O with a velocity of 6 meter per second. The accelerations of P at time t second after leaving O is a meter per second square. where the A is defined as following here. Find the velocity of B at t equal to 1. Okay, so to find the velocity of B at t equal to 1, I will need to integrate this part. Okay, so it will be negative 1.5, negative 1.5. I make the 1.5 become 3 over 2. Then I integrate this. I will get this one as the V equals to the negative t power 3 over 2 plus a C. I need to find the constant C. Then they mentioned that when t equal to 0, V is equal to 6. So therefore 6 equal to the 0 plus C. I have a C equal to 6. Then I have the V is equal to 6 minus the t power 3 over 2. Okay. Then when t equal to 1, my V is equal to 5. Done for the question number 6A. Moving on, 6B. Given that there is no change in the velocity of B when t equal to 1, find the expressions of the velocity of P for t greater than 1. So for t greater than 1 is over here. Okay. So just now I use these accelerations to find the velocity is because this one is including 1. So that's why we choose the first accelerations. Now we want to look for t greater than 1. So to find the velocity, I need to use these accelerations already. Okay, so A equals to the 1.5 t power half minus 3 t power negative half. So I will just take this one out. 1.5, I make it become 3 over 2. Like this. Okay, so this is my accelerations. To find the V, I need to integrate all this here. This is just a simple integrations. So we get the answer t power 3 over 2 minus the 6 t power half and plus a constant d. Then when the t is equal to 1, they mentioned that t equal to 1, the velocity is unchanged. The velocity is referring to the 5. So v is equal to 5. So you have a 5 is equal to the 1 minus 6 plus a d. Therefore, you get the d as a 10. So you have a v is equal to t power 3 over 2 minus the 6t power half plus a 10. Okay, that is a v. Oh, done. We have done the part B already. So now moving on to the part C. Given that the velocity of B is positive, velocity is positive. Okay, for t greater or less than or equal to 4. Find the total distance traveled between t equal to 0 and t equal to 4. Okay, so over here, what is the meaning of this reason? For this, they say velocity of b is positive for less than equal to 4. Means if you try to sketch the graph, if you try to sketch a graph of VT graph, 0 until 4, your graph of the velocity is above, okay, somewhere above. Okay, that means we can integrate directly. We can integrate directly from 0 to 4 without worry that the graph can be below the horizontal line, the x-axis or the t-axis. So over here, this actually try to tell you that you can integrate the formula directly. Just need to integrate directly from 0 to 4 and just using the velocity to find the distance. Okay, so in order to do so, what you need to do is just say that S is equal to integrate from 0 to 4, the VDT. But across 0 to 4, you have a 0 to 1. We have the V1. V1 is over here. Okay, so we have to use this formula for the V1, 0 when it's 0 to 1. So 6 minus t power 3 over 2. Then when it's 1 until 4, you will be using another formula. You will be using this formula. T power 3 over 2 minus t 6t power half. Plus 10 dt. So we just need to integrate them one by one. Over here, you have a 60 minus the 2 over 5 d power 5 over 2 from 0 until 1. Okay. Then this one, it will be 2 over 5 d power 5 over 2 minus the 4d power 3 over 2 plus 10d from 1 until 4. Substitute the value inside. You have 6 minus 2 over 5 minus a 0 plus this one is you just substitute the 4 inside here. 4 inside here, 4 inside here. I straight away press the calculator to save time. So over here, I get this will be 64 over 5 minus the 32 plus the 40. And then minus the 2 over 5 minus the 4 plus 10. And again, simplify everything, total up everything, then you will get the answer as 20 meter. Done. That is the answer for question number 6. And moving on, we have question number 7. Moving on, we have question number 7. Okay, now we take a look at question number 7. We are having a diagram here. Two particles A and B of mass 2 kg and 0.2 kg and 0.3 kg respectively are attached to the end of a light inextensible string. The string passes over a small fixed smooth pulley which is attached to the bottom of a rough plane. Okay. And incline at an angle theta to the horizontal where sine theta is 0.6. Particle A lies on the plane and particle B hangs vertically below the pulley 0.25 meter above the horizontal ground. The string between A and the pulley is parallel to the line of greater slope of a plane. The coefficient of frictions between the A and the plane is 1.125. The particle A is released from rest. Find the tension in the string and the magnitude of the accelerations of the particles. So this one we need to separate them one by one. Okay, we need to separate them one by one, and then we consider them one by one. So right here we will consider at B. If it's at B, the things will be easier because this one is D, this one is mg. Okay, so at B, maybe I just draw the diagram over here. We have the tension here and we have the mg, 3 Newton. So if you resolve the forces vertically at B, you have the 3 minus the D is equal to 0.38. That is your first equations. Okay, but actually the diagram is not needed. Okay, because I want to give space for the A. When A, now A, had to be careful because the surface over here, they mentioned that the surface is rough. So we need to find the normal contact force. So the normal contact force, this is the RA. This is your mg, 2 Newton. Okay, and this is the theta. So if you resolve the forces perpendicular to the inclined plane, it will be the RA is equal to the mg sine theta. Okay. Oh, by the way, I need to have a small diagram here. The sine theta is a 0.6. 0.6 is 3 over 5. 3 over 5, that means 3 here, 5 here, this is a 4. So this one is 2 times 0.6. 2 times 0.6 is 2 times, oh sorry, this is not sine theta, cos theta. Okay, not sine theta. I make a mistake. Mg cos theta. Okay, mg cos theta. So it's 2 cos theta. So it's a 2 multiplied by 4 over 5. You get 1.6 Newton. Okay, 1.6 Newton. Then your frictional force. Okay, your frictional force is equals to the mu RA. So it will be 1.125 multiplied by 1.6. Okay, then you can get 1.8 Newton. Okay, that is your frictional force. And if you resolve the forces parallel to the plane, you will get that the tension plus the mg sine theta minus the frictional force, it will be equal to the ma. Okay, so the tension, we do not know the tension. The mg is referring to the mass of the A. The mass of the A is 0.2. So this one is 2 sine theta minus a 1.8 is equal to the 0.2 A. So you have D minus the 0.6 is equal to 0.2 A. That will be my second equations. Taking the first equation and the second equation, if you solve it together, take the 1 plus 2. You get this one as a 2.4 is equals to the 0.5 A. So therefore your A, your accelerations will be 4.8 meter per second square. So we found the accelerations. Using the equation number 1, you can use equation number 2 also if you want to. I use equation number 1, I get 3 minus the tension is equal to 0.3 times the A that we have just found. Then your tension, just press a calculator, then you get the answer as 1.56 Newton. Done. We have found the magnitude of the accelerations and the tension in the string. Okay, so this is the answer for the part A. Now we're moving on to the part B. When B reaches the ground, it's come to rest. Find the total distance that A traveled down the plane when it is released until it come to rest. Okay, so when B hit the ground, when the B actually hit the ground, then suddenly the tension over here is becomes 0. So we have to recalculate the accelerations after the B hit the ground. So originally the tension, the formula for A is like this. Suddenly the tension becomes 0. So we have to recalculate again. Okay. So at A, I have to recalculate again. So I have a mg sine theta minus a frictional force is equal to ma. Recalculate. So your m 0.2, g is a 10, so it's a 2 sine theta minus a frictional force. Frictional force remain unchanged. Okay, then is equal to the 0.2 a. So my a now has become -3. We are having deceleration right now. Okay, so now it's fully moving down without any external force. Only the gravitational force is pulling the particle down. So you can use the Stewart equations when it comes to rest. So we have a v square equal to the u square plus 2as. We will come to rest. We need to find the speed before before we want to find the speed right before they B hit the ground. Okay, so we will be using the formula. Okay, we'll be using the formula when B reaches the ground. When B reaches the ground, the VB square is equals to the 0 square plus the 2 times 10 times the height. The height is not 10. Just now the acceleration was 4.8, right? In the part A. Just now the accelerations over here is 4.8. 4.8. So 2AH, H will be, the height is 0.25 meter above the ground. Okay, so from here you can find your VB is equal to the square root of 2.4 meter per second. So that will be the speed shared by A. Okay, so the speed of B right before it hits the ground and the speed of A right before B hits the ground, they're sharing the same speed. Square root of 2.4 meter per second. Okay, now we also have calculated the decelerations of A after the B hits the ground. So we will be using this formula. We are using the 0 square at A. 0 square is equals to the square root of 2.4 square plus the 2A S. Okay, so the A I'm using -3, because A, the particle A is having deceleration right now. So you just use your calculator, you can find your S is actually equals to the 2.4 divided by 6. You get 0.4 meter. Okay, so therefore your total distance traveled by A, total distance traveled by A for case A is equals to the 0.25 plus the 0.4. 0.25 plus 0.4, you will get 0.65 meter. Why need to plus 0.25? Because right before B hits the ground, B already travel 0.25. That means A is also travel the same distance, 0.25. So the total distance traveled by A, you need to add together 0.4 with the 0.25. So therefore you get the answer 0.65. And this will be the last part of this questions of this paper. So I'll stop the video here. I'll see you next time. Bye-bye.